Hello, my name is Joshua Gabi. I welcome you to Ionic Chemistry and Qualitative Analysis. And today we are going to discuss about electrolysis. You are welcome. Study the diagram and answer the questions. Study the diagram and answer the questions. And this is our diagram that we want to study, and then we answer the following questions. Look at it carefully and you study it, then you answer the questions that are following it. So the first question is they want us to name the solid P and Q. Solid P and Q. So we have, this is solid P and this is solid Q. They want us to name them. What do you think they are? We have solid P. This is graphite or platinum cathode, and it is connected to the millimeter, which is connected to the negative terminal of the cell. Then we have solid Q. Solid Q is graphite or platinum anode. It is connected to the positive terminal of the cell, and therefore it is the anode. We have our electrolyte. The electrolyte is 2 molar sulfuric acid, and this 2 molar sulfuric acid is our electrolyte, and at this terminal we have gas X, which has been discharged, and at this terminal there is gas Y, which has been discharged. Explain why. Initially, the plastic container was filled with solid magnesium sulphate, and on switching on the circuit, no deflection was detected on the millimeter. However, when water was added to the resultant solution, gave a deflection on the millimeter. So they want us to explain, and they are telling us that initially our container here, which is having 2 molar sulfuric acid, was first filled with solid magnesium sulfate. It was filled with solid magnesium sulfate. And when they switched on the circuit, there was no deflection on the millimeter. There wasn't any deflection on the millimeter. But later on they say that when water was added to the solid magnesium sulfate, it formed a solution. And that resultant solution gave now a deflection on the millimeter. There was a deflection on the millimeter when the switch was closed. That is, afterwards, we had magnesium sulfate, which is solid. There was no deflection. And when we added water to the solid magnesium sulfate, we formed a solution. And when we closed the switch, there was a deflection on the millimeter. So they want us to explain why, when we had solid magnesium sulfate, there wasn't any deflection. But when we added water to magnesium sulfate, we formed a deflection. So here, when we had solid magnesium sulfate, it was in a state which is solid. And in the solid state, magnesium sulfate has no free mobile ions, as they are held by strong electrostatic forces in the ionic compound. So the ionic compound is the magnesium sulfate, and it is solid in the state. That means that the ions are held strongly by electrostatic forces in the ionic compound of magnesium sulfate. Therefore, they cannot move. That's why when we switched on, there wasn't any diffraction, because there are no ions to transport the electrons. But on adding water, the ionic compound dissolves, forming free ions, which conduct electricity, causing a deflection on the millimeter. So after adding water to solid magnesium sulfate, the magnesium sulfate dissolves in water. And when it dissolves in water, it forms free ions. And these free ions that have been formed, now they conduct electricity. And when electricity is conducted, therefore that's why we have a deflection on our millimeter. When 2 molar ethanoic acid was used, a small deflection on the millimeter was recorded. When 2 molar ethanoic acid was used, small deflection on the millimeter was recorded. Explain why. So here we are saying that now, instead of having 2 molar sulfuric acid, we are going to exchange it and use 2 molar ethanoic acid. But when we use 2 molar ethanoic acid, our millimeter shows a very small diffraction compared to what is seen on when we are using 2 molar sulfuric acid. And they want us to explain why is it like that. Why is it that when we use 2 molar ethanoic acid, a small diffraction on the millimeter is the one which is recorded? Why is it small? Ethanoic acid is a weak electrolyte, and hence forms fewer free ions in the solution than dilute sulfuric acid. So when we have 2 molar ethanoic acid and we replace 2 molar sulfuric acid, we are going to see a very small deflection on the millimeter. Why? Because ethanoic acid is a weak electrolyte. Therefore, it forms very few ions in solution compared to sulfuric acid. Sulfuric acid is a strong electrolyte. Hence, it forms very many free ions in solution. And that's why it has a higher deflection, because it conducts more electricity compared to 2-molar ethanoic acid, which is a weak electrolyte and forms fewer free ions. Therefore, its conductivity is lower compared to that one of sulfuric acid. Name the gas X and Y and write equations for the reaction leading to their formation. Name the gas X and Y and write equations for the reaction leading to their formation. So here they want us to mention the gas which is going to be produced here at X and the gas that is going to be collected here at Y. And we also write the equations that lead to the formation of those gases. We are using the electrolyte, which is 2-molar sulfuric acid. So we have X and Y. Which gases are those? Gas at X is oxygen, and the gas at Y is hydrogen. So gas X is oxygen. Oxygen is the gas X, and hydrogen is the gas Y. At the cathode, at our cathode, and this is our cathode, we have our cathode here, P. The hydrogen ions will move to P, and here they will receive electrons and they will be discharged as hydrogen gas. So we are going to have hydrogen gas here, which is Y, because the hydrogen ions will move to the cathode, and when they move towards the cathode, they are going to receive electrons and they are going to be discharged as hydrogen gas. Now when we go to the anode here, the reaction that is going to take place is that the hydroxide ions are going to move towards the anode. And when they reach here, they will lose the electrons and they are going to be discharged to give us water and oxygen gas. The oxygen gas is going to be collected up here and it is X. So the hydroxyl ions are going to be discharged. Let's get this hint. Dilute sulfuric acid contains water. Dilute sulfuric acid contains water. That's why it is dilute. Therefore, the ions present in the electrolytes, we shall have sulfuric acid decomposing to give us hydrogen ions and also giving us sulfate ions. But the solution, we are saying that it also contains water. There is water. And this water gives us the hydroxide ions and the hydrogen ions. Now, the hydroxide ions, being lower in the electrochemical series, are discharged in preference to the sulfate ions. So when you look here, we have the hydroxyl ions that are coming from water, and we have the sulfate ions that are coming from sulfuric acid. So those two anions are going to move to the anode. They will move to the anodes. And when they reach to the anode, one of them is going to be discharged. Will it be the sulfate or will it be the hydroxide? Now we go back to the electrochemical series. Which one is above? You find that the sulfate in the electrochemical series, it is above the hydroxide. Therefore, the hydroxides which are lower than the sulfates are the ones that are going to be discharged in preference to the sulfate. So at our anode, the hydroxides are going to be discharged and we shall get hydrogen or oxygen gas and water. Electrolysis of dilute magnesium sulfate solution and sodium chloride solution gives similar results at the anode and the cathode. Explain, giving reaction equations in your answers. So here they are saying that during electrolysis of dilute magnesium sulfate solution and also the electrolysis of sodium chloride solution, both of these give similar results at the anode and at the cathode. So they want us to explain why, and then also giving reaction equations in our answers. Now, the first thing that we need to find out, what are the ions that are in the electrolytes? What are our electrolytes? The first electrolyte we have magnesium sulfate, and then we have also sodium chloride solution. And previously, our electrolyte was sulfuric acid. So, we want to find out those ions. So our electrolytes that we are interested in, we have dilute magnesium sulfate solution. We need to find out which ions are present. And then we have dilute sodium chloride solution. Here we also need to find out the electrolytes. This electrolyte, which ions does it give us? And then we have dilute sulfuric acid. So those are our three electrolytes that we are interested in. And we want to find out which ions do they give us in the solution. Because here we are seeing that all of them, they give similar results at the anode and the cathode. Let us start with dilute magnesium sulfate. If we look at dilute magnesium sulfate as our electrolyte, which ions do you suspect it is going to produce? So when you look at our magnesium sulfate solution. It is aqueous, therefore it is going to dissociate or ionize and give us magnesium 2 ions and then sulfate 2 minus ions. Sulfate ions and magnesium ions. Those are the ions that are going to come from magnesium sulfate. But remember that dilute magnesium sulfate solution also contains water. So which means that we shall also get hydrogen ions and hydroxide ions. That is from magnesium sulfate solution. Now we want to look at dilute sulfuric acid. Our electrolyte is dilute sulfuric acid. And if it is dilute sulfuric acid, it means that we have sulfuric acid and then we also have water. It is also containing water. So which ions are we going to get from this electrolyte? So our sulfuric acid is going to break down and give us hydrogen ions and then the sulfate ions. That is what it's going to give us. But we are saying that it also contains water. And this water will give us the hydrogen ions and also the hydroxyl ion. So here we have the hydrogen ions that are produced from sulfuric acid and also hydrogen ions from water. And then we have the hydroxyl ions or the hydroxide ions from water and the sulfate ions that are coming from sulfuric acid. Those are the ions that are present in our dilute sulfuric acid electrolyte. Then we have our dilute sodium chloride solution, which is an electrolyte. Can we guess the ions that we are going to get from dilute sodium chloride solution? So sodium chloride solution is going to give us sodium ions. It will also give us the chloride ions. And then from the water, we are going to get hydrogen ions and hydroxyl ions or hydroxide ions. Those are the ions that we have from our dilute sodium chloride solution, which is our electrolyte. So here they are saying that the electrolysis of dilute magnesium sulfate solution, sodium chloride solution, they give similar results at the anode and the cathode. Explain giving reaction equation in your answer. So we want now to get all of them together. We have electrolytes, which is magnesium sulfate, and electrolyte, which is sodium chloride. We can also add on our electrolyte, which is sulfuric acid. And we try to see the types of ions that we are going to get from all those electrolytes. And then we see the reactions that are going to take place on the cathode and also on the anode. Now, when you look at all our electrolytes, we have sodium chloride giving us sodium ions and chloride ions. Then we also have sulfuric acid giving us hydrogen ions and also giving us sulfate ions. Then we have magnesium sulfate, which is giving us magnesium ions, and it is also giving us sulfate ions. So now we have our sodium giving us sodium ions at the same time giving us the chloride ions. Then on the other side, we have water. Water on the other side is giving us the hydrogen ions, and then it is also giving us the hydroxyl ions. So those are the ions that are in our electrolytes, all of them. So now we are going to ask ourselves a question. Which ones are going to go to the anode and which one are going to go to the cathode? Now, the anode being positively charged, it is going to attract the negative ions, which means that on the anode, we are going to receive there the hydrogen ion, the chloride ions. The chloride ions are going to go to the anode. The sulphate ions will go to the anode. And then also here we still have sulphate ions will go to the anode. And then we shall also have the hydroxide ions going to the anode. Now we have three types of ions, all of them going to the anode. We have the chloride ions, sulphate ions, and the hydroxide ions. Now, of all those ones, which one are going to be discharged at the anode? So there now we go back to our electrochemical series or reactivity series. Here you find that sulphate are above the chloride, and then the chlorides are above the hydroxide. So in the electrochemical series, the hydroxide ions are below. And because the hydroxide ions are below the sulphate and the chloride, it is the hydroxide ions that are going to be discharged. They're the ones that are going to be discharged at the anode. And then we shall end up getting oxygen gas and water. So here we are saying that at the cathode, what is going to go there at the cathode? We are going to have the negatively charged ions. All these negatively charged ions, they are going to move and go to the anode. And then at the cathode, there we shall have all the positively charged cations are going to move towards the cathode because they are positively charged. So we are seeing that the cations are discharged as they pick up electrons. That is when they go to the cathode. Hydrogen ions are below magnesium ions and sodium ions. Hence, hydrogen ions are discharged. And when the hydrogen ions, sodium ions, and magnesium ions are transported to the cathode, it is the hydrogen ions that are going to be discharged. And the hydrogen ions are going to receive electrons. After receiving electrons, they will produce hydrogen gas, which is going to be collected at the cathode terminal. So we are seeing that at our cathode, we are going to have all the positively charged ions moving towards the cathode. And when they move towards the cathode, it is only the hydrogen ions that are going to be discharged because they are below sodium and magnesium ions in the electrochemical series. Now, we want to ask ourselves, what is going to happen at the anode? What is going to happen at the anode? What is going to take place at the anode? So we say that at the anode, all the negatively charged ions, which we call anions, they are going to be attracted and taken to the anode. And when they go to the anode, some of them are going to be discharged. Now, which ions have gone to the anode? We have the hydroxide ions, we have the chloride ions, and then we have the sulphate ions. The sulphate ions have gone also to the anode. So which ones are going to be discharged? Now, there we go back to the electrochemical series or electroreactivity series. Yeah, among the reactivity series, the sulphate are above the chlorides, and the chlorides are above the hydroxide. So that means that the hydroxides are going to be discharged. The hydroxides are going to be discharged. And when they are discharged, we shall end up getting oxygen and water at the anode. So here, the anions, our anions, and which anions are we talking about? We are talking about all those anions, the hydroxide ions, the chloride anions, the sulfate anion, all of those ones, we refer to them as anions because they are negatively charged and they are going to be attracted to the positively charged electrode, which is the anode. And those anions are discharged as they lose electrons. So if we have the hydroxide, the chlorides, and the sulfate, all of them moving towards the anode, which ones are going to be discharged? We are seeing that the hydroxide ions are below the chloride ions and the sulfate ions. Therefore, hydroxide ions are going to be discharged. So here we shall have our hydroxide ions losing their electrons and they are discharged as oxygen gas. Then we shall also get water. So that is what is going to happen. That's why we say that when you have electrolysis of dilute magnesium sulfate and electrolysis of sodium chloride, also the electrolysis of sulfuric acid, they give us the same results. At the anode, we are going to get oxygen gas, and at the cathode, we shall get hydrogen gas for all those electrolytes. So thank you very much for participating in ionic chemistry and qualitative analysis. We have been briefly looking at electrolysis. Thank you. Please do like, share, and subscribe.